Hey guys, welcome to Computer Science 401 class. In this particular lecture, we'll be talking about binding time. That's something which may be useful to you in the future. Something like, I guess, in this class in general, it's a higher level class. We're not talking about how to do for loops in Java or how to do I don't know, how to traverse a graph, how to find the minimum or the biggest element in the array. We don't do that. We're talking about something which is much more much higher level, okay, much more abstract, some knowledge which you will may not be that useful immediately, but something which may help you in the future. Okay, so today we're talking about the binding time. Okay, am I recording? Yes, I'm recording. Binding time. Okay, so what is that? Binding time, it is an association between two things, such as a name and the thing it names. Okay, association. So basically, if I say int x is equal to 5, okay, so then like x is the name and 5 is the thing which it names. Hold on, no, 5. No. Yeah, so x is the name and 5 is the thing which x names. Okay, so that connection is called binding. Okay, hold on. That's not binding. So that binding is association. Okay, now binding time is the time at which a binding is created, or more generally the time at which any implementation decision is made. Okay, so at which any implementation decision is made. Okay, so there are quite a few different binding times. So the times where decisions about programming languages are created, made. Okay, so for example, language design time. Okay, so that's the time when people who develop language, they just get together and they're thinking about, they're making decisions about how the computer language should work and should not work. So that's language design time. Now so they talk about that on the abstract level. Language implementation time. Okay, so that's the time when they make decisions, when they actually implement everything which was designed. Developers, of course, right? So program writing time. Okay, what is that? That's the time when developers write the code. Compile time. Okay, so that's the time when the compiler goes through the code and tries to make sure that all the code is valid. The entire code is valid. Okay, that's called compile time. Then we have link time. Okay, if you know Java, you probably remember that each class is located in separate file, right? So every public class has its own public file. Every public class has its own .java file. When they compile, they're being compiled into so-called object files, and then they're being linked. Okay, so the time when there is a linker, there is something which is called a linker, which links them together. For example, it just makes sure that, let's say there is a class called class called human, and there is another class called professor. So professor needs to extend human, right? So they've been compiled separately, but when they linked, compiler just makes sure that that extension is made properly. So the student or professor is properly extending the human class. Okay, link time. Okay, so the time when they linked. Now load time. Okay, so the time when there will be that refers to the point at which the operating system loads the program into the memory. Okay, before executing that. So it's been compiled, now it loads that to the RAM, and then after that we have so-called runtime, and that's basically when the program is being run. Okay, those exceptions which occur at the runtime, runtime errors, runtime exceptions. Okay. 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 Moving on. In any discussion of names and bindings, it is important to distinguish between names and objects to which they refer. Names and objects to which they refer. Okay. And identify several key events. Okay. First key event, creation of object. Okay, objects. Then creation of bindings. Okay, so creation of the connection between the object and what the object is called. Then references to variables, subroutines, types, and so on, all of which use bindings. Next, deactivation and reactivation of bindings that may be temporarily unusable. Okay. Let me correct it here. Reactivation, unusable. Next, destruction of binding. Okay, bindings. And destruction of objects. Okay. Cool. Cool. Okay, moving on. The period of time between creation and destruction of a name to object binding is called the bindings lifetime. Okay. Similarly, the time between creation and destruction of an object is its lifetime. So basically object's lifetime, right, and the variable's lifetime. Okay. Yeah, name to object binding. So binding's lifetime, right, and the object's lifetime, with variable's lifetime. Okay. Okay, so for example, well, hold on. These lifetimes may not coincide. Okay, and that's something which may be important to remember. For example, an object may retain its value and the potential to be accessed even when a given name can no longer be used to access it. Okay, so we have an object, we have a name for it. The name was destroyed, but the object is still there. Okay, so we cannot use the same name, we can use some other name to access it. Okay, so there is some potential to access the object, just not using the same name. Okay. And I think I'm going to give an example. Okay, so for example, when a variable is passed to a subroutine, by reference. Okay, so remember in Java we have pass by value, pass by reference. For example, then the binding between the parameter name and the variable that was passed has a lifetime shorter than that, so lifetime, shorter than lifetime of the variable itself. Okay, so that is this. Let's say you have a variable, you have an object, you pass it by reference. Okay, so the variable is created in that subroutine, which refers to that object. Now, at the end of that variable, at the end of the method, that reference, that variable is being destroyed. However, the object still exists, and you can still access it using some other ways, right? So in the parent, in the method which called that subroutine, you still have a way to access that object. Okay. Right. To my reference. No past. Okay, cool. So now check this out. It is also possible, although generally considered to be a bug, for name to object binding to have longer lifetime than that of the object. Okay, so imagine this: you have a binding and you have an object, and that binding exists longer than the object itself. So basically, at some point, it's possible that you would try to access the object using the binding, but the object was destroyed. Okay, that can happen. Lifetime, let me correct some mistakes, have longer lifetime. Okay, that can happen if an object created via the C++ new operator is passed as a ampersand, right? So as an address, as an ampersand parameter, and then deallocated. Okay, deallocated before the subroutine returns. Okay, a binding to an object that is no longer live is called Dangling Reference. Okay, so that's actually a very, very popular question on the interview. What is a dangling reference? Okay, so you should definitely remember what that is. One more time. If you create a variable, right? So, for example, in Java, that's unlikely to happen. It's very difficult to. Well, I think it's possible to happen in Java. It's just very difficult to make it. You will not be able to provide an example. But in C, in C++, in C++, all of those languages where you manage memory yourself. So one of the biggest differences between Java and all the C languages, apart from C#, I think, okay, is that Java has the so-called garbage collector. Basically, in C++, when you want to create an array of some amount of elements which you do not know yet, right? You have to use a command so-called memalloc, memory allocation. Okay. Yeah. So you create some amount of memory, then you fill that in with the values, and then if you do it manually, if you manually create that, if you manually allocate memory, then you have to deallocate it later. Okay, so you have to destroy it yourself. Meanwhile, in Java, if you create an array, it's being created for you. If you and then it's being destroyed for you automatically. So that's called a garbage collector, right? So it automatically picks up all the garbage and destroys all the variables which are not needed. Okay. Anyway, so let's say in C, if you create an array, okay, and then you destroy an array, but the name is still there for that array, okay. Now, when you try to, it's possible that due to some circumstances, you still trying to access that array using that name, but that points to nowhere. It points to some location memory which is already being used by some other process. Okay, so that is called dangling reference. So reference, a name of the variable which points to nowhere, points to the location of the memory which you cannot access anymore, right? Because it was kind of, that variable was already destroyed, but the name wasn't. That's called dangling reference. Okay. So in other words, a binding or a reference to an object that is no longer live, that is no longer used, that is no longer can be used, is called dangling reference. Okay, cool. Hope it makes sense. Moving on. Next topic: static allocation. Okay, so for this lecture, maybe for the next one, maybe for two more, we'll be talking about the ways memory can be allocated in different programming languages. Okay, well, yeah. So one of the ways to allocate some amount of memory is called static allocation. Static. Okay, there are a couple of ways of doing that. So static allocation is one of them. Okay, now global. So today we'll be talking about static allocation. Okay, global variables are the obvious examples of static allocations. Okay, so in almost all the programming languages, all the global variables are allocated in static memory. So, well, no, I should not say that. So, in the majority of programming languages, global variables are allocated statically. That's a better way to say it. Okay. Well, okay, hold on. Before we get to this, we should probably talk about what methods are there in general. Okay, so storage allocation methods. Okay, the first one is static allocation. So static allocation. Okay, so static objects are given an absolute address that is retained throughout the program's execution. Okay, that's static allocation. Stack based allocation. Okay, so stack objects. Okay, so static is for global variables. Okay, now stack based allocation. Obviously, they're created on a stack. Stack objects are allocated and deallocated in last in, first out order, usually in the conjunction with the subroutine calls and returns. Okay, so the idea is this. Let's say you have a main method and you have some other method. So that main method calls that some other method, and in that other method, which is being called, there are a couple of local variables. So those local variables are going to be created on the stack. They will be created using the stack-based allocation. Okay, and now heap. Yeah, so basically all the variables, everything which you have in the memory can be separated into three categories, right? So there will be static, right? Stack-based, they'll be created statically, they'll be created on stack, and they'll be created on top of the heap. So heap objects may be allocated and deallocated at arbitrary times, okay? What does that mean? That means user or programmer, the person who creates those objects, he actually decides when to create and when not to create them. Okay, so they require a more general and expensive. General and expensive storage management algorithm. Okay, more general and expensive storage management algorithm. Yeah, so because the idea is that you have to do everything yourself with the heap based. Okay, so static. Yeah. Okay, coming back to static allocation. Okay. Okay. Numeric and string valued constant literals are statically allocated. Okay, those are like the examples. Statically allocated for statements like a is equal to b divided by 15, and print f. Okay, so printf is like kind of like system.out.println, but for C. Hello world. Okay. Printf hello world. Yeah. So again, that 15 and that hello world. Okay, so those are going to be statically allocated. Okay. Also, most compilers produce a variety of tables that are used by runtime support routines for debugging. Okay, dynamic type checking, garbage collection. Okay. So debugging, what is debugging? I hope you already experienced. I hope you use debugger in Eclipse. The idea is that, let's say something is wrong with the code, you have no idea what's wrong with this, right? So just everything works fine. There are no runtime errors. The problem is that the output is not what you needed, not what you wanted. Okay, so how do you solve it? You need to run the debugger. Debugger is basically is something which is going to execute the code up until the main method, and then it's going to stop, and that's going to tell you, okay, so look, at that moment of time, x is equal to 5, I is equal to 2. It's going to give you the values of all the variables, and then there are buttons, so you can say, for example, next function, and it's going to step. It's basically it's like step to the next statement. It's going to highlight that in green, and it's going to step to the next line. It's going to execute that. It's going to also show you the current situation in the program, what all the values are equal to at that particular moment of time. Okay, so in order to support all of that, they need lookup table, okay, and they are created also statically. Dynamic type checking. Okay, so for example, if you remember in Java we have generics. Okay, so you saying like you created a generic type called T, okay, and then let's say you have bounded generics. Okay, so like for example upper bound. So you, for example, you say T and then you say T like I don't know, question mark extends T. Okay, in this case there is no way for you to know if the code is going to work until the runtime. So during the runtime, Java virtual machine is going to see, okay, is the type which you provided actually extends that T type. Okay, so that's dynamic type checking. Garbage collection, we already discussed all of that. So whatever you create, all the variables you created, they need to be destroyed at the end of the method, at the end of the program. So garbage collection is a feature which actually made Java stand out back in the day when it was just developed compared to C++. So again, back in the day when C++ was very popular, Java was developed, and one of the features which people loved about Java is that they have garbage collection. Meanwhile, in C++, programmers had to manage all the memory themselves. What else? Okay, yeah. So in general, statically allocated objects whose value should not change during the program execution. Okay, so for example, instructions, constants, certain runtime tables. Okay? Yes, statically allocated objects whose values should not change are often allocated in protected read-only memory, so that any any unwanted attempt to write them will cause a processor interrupt, allowing the operating system to announce a runtime error. Okay, so one of the other things to remember, there are some pieces of the memory where you should not actually mess with at all. Okay, so for example, do you know what happens when you push the start button on the computer, the power button? What happens is that the processor is turned on, okay? Then it actually looks at, I forgot what the register is called, but basically there is a routine which is going to be executed every time you push the power button on the computer. And that thing is, that routine, of course, it's located in the memory, most likely in the BIOS, like a basic input-output system. And nobody wants you to be able to mess with this. Because if you actually screw up how the computer behaves when the computer is turned on, when you just push the power button, of course your computer will not be able to reboot, restart again, ever. Okay, it will not be able to work again. So that's why that's located in so-called read-only memory. So nobody will ever be able to change something there. Okay. And if you try to do that, then operating system will say, well, first of all, it will forbid, and then operating system will say, okay, look, that's probably a virus, or you're not doing, or you don't really know what you're doing. Just please stop. Please stop. Okay, cool. So let's stop right now. We'll talk more about static allocation and all other types of allocations next time. Okay, so we also have stack and heap. Okay. And I'll see you guys, I guess, in the next lecture. See you later. Bye-bye.